In this video, I want to take a moment and compare correlation and regression. Correlation, we're looking at whether changes in one variable are associated with changes in another variable and how strong that association is. In regression, we're asking if changes in one variable predict changes in another. And the difference is, in correlation, the relationship goes either way. If our x variable is correlated with y, and we have some correlation of coefficient that tells us how strong that is, the exact same relationship holds in the opposite direction. So y being correlated with x with the exact same correlation coefficient. All we're saying is that when we measure one variable, we're seeing similar results, consistent results with the other variable. Regression, the word predict means if we have the value of the x variable, we can predict or make a guess at what the value of the y variable is. So that's not bidirectional, right? So if we have the linear regression equation, that r squared is about how well x predicts y, not y predicting x. And predict is also not the same as cause. So just like with correlation, we're not looking at a causal relationship, because what we're doing is we're taking a sample, we're plotting it out, these x and y variables, and then we're just looking at, well, how well does this line fit what we saw? We're not making changes within each individual person. We're not taking a person and assigning them a value on this x line, or we're not measuring what their x value is and then changing it to something else and seeing what happens up here. We're simply looking at, well, here's a bunch of different people with different x values. Here were the corresponding y values. How well can we fit a line between them? Some of the symbols that you're going to see when we're discussing correlation and regression. So the correlation coefficient we've covered. That's how linear is the relationship. And when you get a p-value in correlation, you're getting the probability that you saw the data you saw if r was actually 0. And when you get the confidence interval, that's going to be on the correlation coefficient, and you want to know if 0 is within that confidence interval. Coefficient of determination, r squared, that's for linear regression, and that is actually this r squared. So these are the same things. One is just squared. And this is telling us how accurate are our predictions. So if I give you an x value, you plug it into that equation, how accurate is the y that you're getting with? And you're not getting a p-value or a confidence interval for that r squared. Beta is the slope of the line. So that's this linear regression line. Beta is the slope. And it's telling you how big a change in y do you see when you get when you see a 1 unit change in x. And your p-value for linear regression is giving you the probability that you would get the observations you saw even if beta was 0. And the confidence interval for linear regression is going to be on beta. And you want to know if the slope of beta is 0. That you want to know if 0 is in that confidence interval.